In this lesson, you're going to learn about the different properties there are in math. Our first property is the commutative property. When adding or multiplying, the commutative property allows the values to switch places. This is allowed because switching places will not change the actual solution. For example, let's say we had 5 plus 3. If we were applying the commutative property, that means that we could switch those values, meaning 3 would become where the 5 is, and the 5 would be where the 3 is. Now our solution should still come out to be the same. 5 plus 3 is 8, and 3 plus 5 is 8. So this is what allows our commutative property to be true. So all you have to remember for this particular property is that you're switching spots, or you're flip-flopping. So sometimes I like to call the commutative property the flip-flop property. Again, this works for addition and multiplication only. If we were to apply the commutative property to subtraction or division, our answers would be totally different. So just remember, it's only for adding and multiplying. Our next property is the associative property. This allows regrouping of values using parentheses to show this. The order of the values generally do not change, just the grouping. So let's say we had something like, in parentheses, 2 plus 3, close parentheses, plus 5. When applying the associative property, we're going to keep the order the same, 2 plus 3 plus 5. The only difference is where we're going to group the numbers. Since before we grouped our parentheses around the 2 and the 3, this time we're going to group the parentheses around the 3 plus the 5. Now, in order to solve this using order of operations, when I solve the left-hand side, 2 plus 3 is 5, and 5 plus 5 equals 10. On the right-hand side, I would need to do the 3 and the 5 first. 3 plus 5 is 8, plus 2 more is going to give us 10. So notice how both sides are equal, making this property true. Again, the thing that you have to remember about the associative property is the order generally stays the same. The only thing that's different is where the parentheses are associating themselves. Our next property is the distributive property. This can be one of the trickiest properties because it involves multiple operations. Now, when I think of the word distribute, I'm thinking giving out or handing out. If I were to distribute paper in class, I would be giving each of you a piece of paper. Well, the same thing kind of applies, except in this case, we're dealing with numbers. Let's say we had the example 3, and then in parentheses, 4 plus 1. I want to apply the distributive property by distributing the number on the outside to the numbers on the inside. In this case, the 3 would be distributing to the 4, and the 3 would be distributing to the 1. Now, what does this mean? Well, when the 3 is being distributed to the 4, that operation that's taking place there is multiplication, because when there's no operation in between here, it is understood to be multiplication. So this would look like 3 times 4, and then because we're adding here, we're going to put an addition sign over here, and then we've got the 3 times the 1, so I would have 3 times 1 here. Now, to prove whether or not this theory of the distributive property works, we can use order of operations to solve just like we've done with the other properties. If I were to take care of the parentheses first, 4 plus 1 is 5. And again, I'm going to keep that in parentheses to show multiplication of 3. And 3 times 5 is 15. I'm going to do the same thing on the other side using order of operations. I'm going to take care of my multiplication first. 3 times 4 is 12. I'm going to bring down my plus sign. 3 times 1 is 3, and 12 plus 3 is 15. So because 15 is equal to 15, this property is true. The biggest thing that you need to know about the distributive property is that multiplication is always going to be involved. When the 3 in this case goes with the 4, it means 3 times 4. And then it also has to multiply by the second number that's in the parentheses as well. In this case, it was the 1. So again, when you think of distributive property, think of passing out something. And in this case, the 3 was passing out to the 4 and to the 1. Our next property is the additive inverse property. It's exactly what it means. You're adding its inverse. So in this case, you're adding its opposite. So if I have the number 7 and I wanted to add the opposite of 7, which is negative 7, that's going to give me 0. And that works for anything that we add the opposite to. So it's exactly as the title says, additive meaning adding, inverse meaning opposite of whatever that number was. and your answer will be 0. Our next property is the multiplicative inverse property. Very similar to the additive inverse property, except this time we're going to be multiplying. And whenever we're multiplying, instead of using the opposite, we're going to be using the reciprocal. So let's say we had the number 5, and we wanted to multiply by its inverse, or its reciprocal. 5 is technically 5 over 1, and when we multiply that times its reciprocal, which is going to be 1 over 5, our answer is going to be 1. Now you might be wondering, why would our answer be 1? Well, if we cross-simplified the 5s, they would turn into 1s. 1 times 1 is 1, 1 times 1 is 1 again, and 1 over 1 is still equal to 1. So anytime you see the multiplicative inverse property, just know that you're multiplying by its reciprocal and not its opposite. And again, we use the reciprocal because it's multiplicative. Our next property is the zero property. This is one of the easiest properties out of them all. It's exactly what it's saying, zero property. So we're going to be dealing with 0 here. In this case, zero property means that you're going to be multiplying by 0. And anything multiplied by 0 is going to give you 0. So if we had something like 8 times 0, our answer is going to be 0. So just know that whenever you see the zero property, you have to be multiplying by 0 to get 0. A lot of times some students get confused with the additive inverse property because when you apply that property, you get a 0. Just know that with zero property, again, you have to be multiplying by 0 to get 0. Our next property is the identity property. When I think of identity, I think of somebody who wants to be true to themselves, and that's exactly what the number wants to do. So you have to think, what could you add or multiply to a number in order to keep that same number? If I had the number 9 and I wanted to add some type of number to it to still give me 9, I would want to add a 0. 9 plus 0 is 9. Even though we were adding 0 to it, the 9 still stayed true to itself because 9 plus 0 is 9. Now, let's say I had 9 and I wanted to multiply by some number to still give me 9. I could multiply by 1. 9 times 1 is 9. Even though 9 was being multiplied by 1, it still stayed true to itself because our answer remained as 9. So our identity property deals with basically adding 0 or multiplying by 1. You always want your value to come out to be the same, no matter whether you're adding 0 or multiplying by 1.